Hi, my name is Christine G, and I'm going to be going over this problem from Mobius. It's in Module 3, and I believe it's problem number 11. So here we have, and I've changed the numbers, so it's not the exact same problem. So a tumor is injected with 0.2 grams of iodine 125, which has a decay rate of 1.20% per day. Write an exponential model representing the amount of iodine I-125 remaining in the tumor after T days. So here, what we are going to do, let me clear this out, and we'll call this, we'll put in 8 days. I forgot to write a number in there. And we have the continuous growth formula. So right now, we know that A naught, or A sub 0, is equal to 0.2 grams of the iodine 125. And it has a decay rate of this 1.20%. And when we think of the decay, that means it's going down by that per day. So if we think of buying, let's say, a dress that is 20% off, or pants, let's say pants, and the pants are 20% off. Well, if they're $100 pants, how much are they going to cost? Well, the easiest way to do that is to say, okay, 100% minus 20%, and that will give us 80%, or 0.80, and multiply that by 100. So same idea here. We're going to take this and subtract it from the whole 100%. So here, what we do is we say, okay, 100, let's just say 100% minus, and then this is 1.20%. Okay, and I'm just going to stick that in my calculator and just say 100 minus 1.20. And then I come up with 99.988%. Okay, so now that is, I know that this, if I convert it to decimal, it would be, I'd move it 2 places to the left, and it would be 0.99988. And that would be multiplied by the original to give me the amount that is left after 1 day. So what I'm going to do here, because I don't have A, but I can get it by multiplying 0.99988 times A naught. And I could put in 0.2, but I'll show you here. And then I would put in the 0.2 in both places, equals A naught, and then E to the power of K. And then we're going to put the time in as 1. Why? Because this is after 1 day what our value for A would be after 1 day, because we're just taking, just like we did here, 100 times 0.80. That's after the discount, and we can think of this as the decay as working the same way. So now what we can do, though, we could put the 0.2 in for A naught if we wanted to, but we don't have to, because what we can do instead, let me try and do this instead of rewriting the whole thing. We can, right now, A naught is being multiplied here. So we can, and it's being multiplied here, we can divide by A naught on both sides, and guess what? They cancel out. How nice is that? So A naught divided by A naught is just 1, and 1 times is 0.99988. And then we just have E to the power of K. So now our goal is we want to find out what K is. And so we need to, now we have everything all isolated, and we can Find out what k is by taking the natural log of both sides. So I'm going to take the natural log of 0.99988. And then when I take the natural log of e, these are inverses of each other. So they will cancel and bring down k. And then we just have k is equal to the natural log of 0.99988. Phew! So now we have what k is. We can go back to our original formula and we can put in a equals, and then a sub naught, which is our 0.2, e to the power of k. So we're going to write this guy, natural log 0.99988 times t. And we can write it with parentheses like this. And then you'd put in however many days and simplify that. So hope this is helpful, and please let me know if you have any questions. Thanks so much for watching. Have a great day.